Hello, everybody. Welcome back. Today we are going to be doing the power rule. So, just a reminder so far, what we've learned is we've learned how to find the derivatives from first principles. But there's a new rule that's going to make it a lot faster to figure out the these derivatives. And that rule is called the power rule. But before we get into that, I want to talk about the constant function rule. Basically, if f of x is equal to c, where c is some constant number, doesn't matter what, then the derivative is 0. So for example, if f of x is equal to 10, right? 10 is just some number, some constant. That means f prime of 10, or f prime of x is equal to 0. So we take the derivative, we get 0, right? What if f of x is 25? Same thing occurs at 0. What if it's negative 102.78? Same thing. And so any constant number that does not have an x beside it, right? Any constant that is not a coefficient, but just a constant number, the derivative is 0. Okay? So that's the constant function rule, is that the derivative of any constant function is 0. And that's actually a special case of the power rule, which we'll get to in a minute. And I'll explain how it's a special case of the power rule in a moment here after I talk about the power rule. The power rule states that if we have x to the power of n, then the derivative, take the derivative, we put the n out in front, and then we subtract 1 from the n as our new exponent. So I'm going to give you a quick example. If I have f of x, if I have f of x is equal to x squared, that means that f prime of x, right, our derivative is going to be 2x to the 2 minus 1, right? Notice how here I put my n, which was 2 out front, right here, and then I subtracted 1 from the exponent, so 2 minus 1. 2 minus 1 is just 1, right? So 2 to the x to the power 1, which is going to just be 2x. So the derivative of x squared is 2x for that reason, right? And because the first principles would also suggest that as well. But in terms of our power rule, that's the reason. I'm going to do one more example quickly, just one more very simple example to get us going. What is the derivative of f of x is equal to x cubed? Well, the derivative is equal to 3x to the 3 minus 1, which is 3x squared. So 3x squared is our answer. So now I'm going to answer the question as to how this constant function rule is actually is actually a specific case of the power rule, right? Because the thing is, a constant function, right? Let's say it's let's just put c as an example. C is the same as c times x to the power of 0, right? X to the power of 0, right? So if we were to apply this rule here, we would get 0, right? If we were to apply our rule, we would end up with 0. And so the constant rule is actually a variation of the power rule in that sense. All right, now let's go through some more examples using this power rule. Let's start with this one, for example. The derivative here is going to be 7 times 3, right? We're going to take this 3 and put it in front with the 7. X to the power of 3 minus 1, right? Because in the rule it states we subtract 1. And now I'm going to simplify that and say, well, that's going to be 3 times 7, which is 21, x squared, right? X to the power of 3 minus 1, hence x squared. All right, how about this one? Y prime, the derivative, would be equal to 8 times 4 over 3, right? We're taking the 4 over 3, the exponent, and we're putting it out in front. X to the 4 over 3 minus 1. Now, let's move on. 8 times 4 is 32, so this is 32 over 3. X to the power of 1/3, right? Because 4 over 3 minus 1 is 1/3. Good. All right, now this next one is a little bit trickier. How do we deal with square roots? Well, keep in mind that we can rewrite this. This is the same thing as x to the 3 over 2, right? Because we recall from probably grade 10 or 11, depending when you learned this, maybe grade 10, maybe grade 11, recall that the root is really just the same thing as the the denominator of the power, right? Recall that the nth root of x is equal to 1 over n, right? So all I did is I said, well, this is the square root, and I said, well, then it must be 3 over 2. Good. Awesome. So now that we know this is actually equal to x to the power of 3 over 2, what is our derivative? Our derivative is 3 over 2 x to the 3 over 2 minus 1, which is equal to 3 over 2 x to the power of 1 half, which you could also say, well, that's same as root x as well. But either way is acceptable. Okay, let's find the derivative of this one, and let's note quickly that this is the same as 5x to the power of 4 minus 2x to the power of 1 half. Now keep in mind here, this is the first example where we actually have two constants, right? Or not two constants, two terms here, right? We have 5x to the power of 4, and we have negative 2x to the power of 1 half, right? We have two separate terms. And what we do when we have two separate terms that are just being added or subtracted is we can just use the power rule twice, once for each term. So to use it for the first term, I'll say this is equal to 20x to the power of 3, right, for the 5x to the power of 4. And for the second one, it would be 2 times a half x to the a half minus 1. And what's that going to be equal to? That's going to equal negative x to the negative a half, like that. Now, you could stop there, or you could go a step further and say, well, negative a half, that's the same as 1 over root x. So you could write it in this form, or you could keep it in the form from before. It just depends on your teacher's preference. Okay. Now for this one, this says to find the derivative of this function squared. Now, in the chain rule and actually product rule as well, actually, we're going to learn two other ways that we could figure out this question, but we have not learned those rules as of yet. So I'm going to show you, if you just want to use the power rule, how we can solve it. So in order to just use the power rule for this, with that knowledge and no other knowledge just yet, what I'm going to do is first I'm going to expand my brackets, and I'm going to get 16x squared, which is going to be 256 x squared. Let's see, double the product, so 2 times 16 times 2 is 64, so negative 64x, and then plus 4, right? So this is equal to this. And keep in mind, this polynomial has three terms in it, right? 256x squared, negative 64x, and plus 4. So to find the derivative, we must apply the power rule twice, and then the constant rule once for the 4. So let's see here what we'll do. So 256 times 2 would be 512. And then the x squared becomes just x, right? So just x. And then here we're going to subtract 64, right? The power of 1 here just gets multiplied by negative 64, and then it subtracts off, so we get x to the 0, which is 1. And then we don't have to add anything else for this plus 4. We can just ignore this term because we know that the derivative of any constant is just 0. So we could write plus 0 here if we wanted, but I'm not going to bother because that wouldn't really change what we're doing, right? Okay. All right, let's go through a few more examples, and then we'll move on to some other rules. This one says, write the equation of the tangent line to f of x equals negative x cubed plus 4x squared at x equals 1. Okay, so first let's find the equation of the tangent line in the first place. So the equation of the tangent line to this function is the derivative. So we know we're taking the derivative. Given that this is the power rules lesson, we can probably guess we're supposed to use power rule here. And if we look at the question, we can see there's two different powers. So that's also another reason how we know for sure we should use the power rule. So let's do it. For our first term, minus x cubed. Mhm. We're going to get minus 3x squared. For the second term, we'll get 4 times 2, x to the 2 minus 1, and then no other terms. So then let's just simplify that a little bit further. And there we have it. And now it asks specifically at x equals to 1. So for the next step, I'm just going to plug 1 into my equation. And then we end up with negative 3 plus 8, which is going to be 5. So therefore, the slope of the tangent when x is equal to 1 is that is 5. Now, notice here, they didn't just ask the slope of the tangent, they asked the equation of the tangent line. And remember that the equation of all lines, recall that y equals mx plus b, where m is our slope and b is our y-intercept. So we just found the slope, but we did not find the y-intercept yet, the b value. Now, what do we know, right? What do we know about this? We know that x is equal to 1. So what would y be equal to if x is equal to 1 is our question here, right? So if that's the case, if that's the case, then we have So if that's the case, then we need to plug in 1 into our original equation to find the y value. When x is y, or sorry, when x is 1, what is y? Well, let's see. Negative 1 cubed plus 4, 1 squared would be negative 1 plus 4, which is 3. So therefore, we have the slope of the tangent line, which is 5, right? We established that earlier. And we have that a point on this tangent line is 1 comma 3. So what I'm going to do now is I'm going to solve to find the b value. So therefore 3 is equal to 5 times x, which is 1, plus b. So therefore b is equal to 3 subtract 5, right? So therefore b is equal to minus 2. So therefore the equation is y equals to 5x plus b, which in this case is negative 2. So subtract 2, and then we are good to go. All right, well, that's that. All right, let's do one more example. All right. Example 7 says, determine the points on the graph of the function g of x is equal to negative x cubed plus 3x squared minus 2, where the tangents are horizontal. So let's see here. If the tangents are horizontal, what does that mean? Well, a horizontal line has what slope? A slope of 0, right? So because a horizontal tangent line means that the slope of the tangent line is 0, that tells us that the derivative, g at x, this derivative must be equal to 0, right? So therefore, in order to determine the points on the graph where this is true, we've got to solve. So we know g prime of x is 0. What else is g prime of x? Well, if we use the power rule, we can find out it's also negative 3x squared plus 6x. And then, again, that this is just a constant, so it just disappears. And so we can say, well, therefore 0 is equal to negative 3x squared plus 6x. So therefore 0 is equal to negative 3x squared, or sorry, negative 3x times x minus 2. So therefore, using our product property, right, our zero product property, we can say therefore x is equal to 0 or x is equal to 2, right? Now notice it asks determine the points on the graph, not just the x values on the graph, but what are the points? So to find the rest of these points, I need to go with g of 0 and find out what that is, and also g of 2 to find the y values. So let's do that. Here we just have 0 plus 0 minus 2, which is just negative 2, so that one's easy. This next one is going to take a little bit longer, but that is okay. 3 times 2 squared minus 2. So that's going to be negative 8 plus 12 minus 2, which is going to be, let's see, 2. What? Uh-oh. Let's see, we have 0, negative 2, 0, 2. Okay, because we can never have the same input given two different, but that would be okay anyway. Okay, no, we're good. All right, so therefore, the points are 0, negative 2, and 2, 2, right? Now, why are those the points? Because those are the points that we found when we set the derivative to 0. And we set the derivative to 0 because it says that the tangents are horizontal, right? And what slope does a horizontal line have? A horizontal line has a slope of 0. It does not have a slope. Good. All right. Let's go to this next one. This next one says, determine the points on the graph of the function where the slope of the tangent is parallel to y equals 5x minus 3. Illustrate with a sketch. Okay, so for this one, it says that the tangent is parallel to this line. So what do we know about parallel lines? We know that parallel lines have the same slope. So in this case, we want to set h prime of x equal to 5. Why? Because we know that the slope of this tangent line, it has the same slope as this other line, right? Because it says the lines are parallel. So that's how we know. Now now back to the main point here. What else is h prime of x? If we take the power rule here, we'll get negative 2x plus 3, right? So therefore 5 is equal to negative 2x plus 3. So therefore negative 2x is equal to negative 2. So x is equal to 1. Now it says determine the points on the graph, right, where the slope is there, right? And so again, we need to plug in h of 1 in order to find the y value. Okay, so let's do that. Let's see. Negative 1 squared plus 3 times 1 plus 4 is equal to negative 1 plus 3 plus 4 is equal to 6. So there we go. So therefore, 1, 6 is the point. Is the point on this graph where the slope where this function has a slope of 5. All right, it also says to illustrate with a sketch. I don't think that part is that important, but what they mean by that, if we wanted to go through with that, is to go ahead and draw the quadratic. So sketch the quadratic, and then also sketch this, the approximate tangent line showing, oh, the slope looks like it's about 5 there, right? As it's parallel to this other line, which is 5x minus 3. All right, very good. All right, well, that is it for the power rule. Next time we will talk about the chain rule and the product rule.